All right. Hey, AP Chemists. This is the Summer Work Important Information Part 3. This is the Part 2 video. We'll be talking about atomic level view of elements and compounds. This is very important for us to be able to look at and know pictures and represent them as elements and compounds and ionic compounds and molecular compounds and knowing that difference. I did write on these like before, so you might want to pause and write it and follow along or see if you could follow along as I'm speaking. I wanted to remind us, and I don't know if we caught this in the part 2, or the part 2 summer lecture series here, but when I represent or talk about particles, there are two different types, or two major different types of particles. Atoms, which I could say also ions, maybe. Atoms or ions. I'll just mostly focus on atoms right now. Atoms or molecules. Atoms are these individual circles. Molecules are kind of doubled up or tripled up or more than one atoms combined to make molecules. And I kind of did a little math here to show you. This picture on the left, I have 4 particles in here. 1, 2, 3, 4. And those 4 particles are 4 atoms. The picture on the right, I have 4 particles, 4 molecules. 1, 2, 3, 4. Notice how those doubled up circles, they are considered one particle, but those 4 particles altogether have 8 atoms. Each particle has 2 atoms. There are 4 particles, therefore 8 atoms. Know how to count and do that math there. Recall that we could categorize pure substances as elements or compounds. Elements can either be atomic or molecular. And again, atomic, 1 circle. We'll see that molecular will be kind of doubled up circles. And then compounds can either be molecular or ionic. And we'll see that molecular, that's 2 nonmetals, if you remember from the previous lecture. And ionic would be metal and nonmetal. We'll see that ionic will have ions as the base unit, and molecular will have molecules as the base unit. Okay? All right, so here are our classifications here, and I kind of wrote on them already. We have our pure substances, elements, like on the periodic table, right? So like iron, or beryllium, or strontium, right? Those are different elements. Elements are the same type of particle, but they would all be one color. So elements are going to be the same type of particle and only consist of one color. This could be the blue and the red that I have here, or it could be shaded and unshaded. Just know that if I only have one color, I'm only going to have an element. Now, those elements can either be atomic or molecular. And so an atomic element would be single atoms, one color. So here is the atomic element of neon, single atoms, one color. Or elements could be molecular. They are molecules, 2 or more combined. There's a molecule, all one color. Molecules that are one color would be a molecular element, and we're going to talk about molecular elements below here. Then we have compounds. Compounds could also be molecular. However, a molecular compound will have 2 colors. The individual particle will be a molecule, but that molecule will consist of 2 or more colors. And a compound could be ionic. Again, 2 or more colors. However, look at the big difference between molecular and ionic here. It looks like this ionic, they're all touching. They're all connected. An ionic structure or compound would have all connected particles. But look at molecular. There are no connections between particles. So that's going to be big. A big difference between molecular and ionic is there are no connections. They both have 2 different colors. That's great. But there are no connections in molecular between particles, and all particles are connected in ionic. And then, of course, atomic and molecular, there are no connections between particles either. There are no connections. So if you see, there are no connections between particles. It's just empty space there. And now to further talk more about atomic versus molecular elements, there are going to be 7 elements that you need to recognize and know are molecular elements. And the way that I love to remember it is by this phrase called Hofbrinkel. This phrase represents something called diatomic elements. They exist as molecular elements. Here they are. Here are the element symbols. We have H, O, F, Br, Cl, I, N. I mean, not in the right order, but I'm just putting boxes around them. Hofbrinkel is just an easy way for me to remember it. H2, O2, F2, Br2, I2, N2, Cl2. If you hear any of these element names, you automatically have to know that they are diatomic elements. And here's an example. Here is chlorine. If I hear chlorine, that is Cl2, and this is how I would draw chlorine molecules. They are an element, but this is a molecular structure, molecular element. Boom. That's how I would label it. It is an element. It's in Hofbrinkel. It would have to exist as molecules. There are 4 molecules. 1, 2, 3, 4, as I just quickly drew them. And each of those molecules have 2 elements. So that is a total of 8 atoms. Okay? And then I just want to bring it home here, the difference again between molecular and ionic. Just to simplify or summarize, a molecular compound and ionic compound, both of them would have 2 different colors. But as you could see, for a molecular compound, there'd be 2 colors with no connections between particles. And an ionic compound would have 2 colors where they would be all connected between particles. Done. To end, I'm going to slowly introduce us into something called polyatomic ions, which are a little bit special here. When molecular meets ionic. And so I'm going to name them here. I'm going to use a different color. I'm going to use like purple. NH4 plus is something called ammonium ion. SO4 is something called the sulfate ion. NO3 minus is called the nitrate ion. And OH minus is known as the hydroxide ion. All of these, as you could see, are 2 or more atoms, let's say nonmetals, combined to give an overall charge. And so this ammonium ion, I'll look at this firsthand here. This is what its structure would look like, as we saw in the previous lecture, like what a structural compound is. This is NH4. It has 2 different nonmetals in it. It has N and H. We would think that 2 nonmetals bound together is a covalent or molecular compound, but overall it has a charge of +1, ionic. So something to know is if I ever see a polyatomic ion in a compound, I need to know that the polyatomic ion contains molecular bonds and can also form ionic bonds. So an example would be like NH4Cl. This is something called ammonium chloride. It has the ammonium polyatomic ion. This ammonium has molecular bonds, and it is ionically bound to Cl. So this is molecular and ionic. So just ending here that if I see anything with a polyatomic ion in it, any one of these 4s are these. I would recommend you memorize these 4. These are major polyatomic ions. If I see them in a compound, I think ionic, but I also have to think it's also molecular. All right, so now you are just going to do exercises 4 and 5 here. I kind of got you started and gave you some answers. So for exercise 4, you're going to classify each substance as an atomic element, a molecular compound, or an ionic compound. I'm going to help you out. Xenon is Xe, bromine is Br2. So I did an example here. E is NaNO3. NO3 is the nitrate ion, and I had to think, if I see a polyatomic ion in a compound, I have to think it has both ionic and molecular compound. Boom, I gave you the answer to E. And then I also did G here. Looking at this structure, I see two colors, and they are all connected, so I would consider this an ionic compound. Now, look at the other examples here and identify them in a similar way. Is it an atomic element? Is it a molecular element? Is it a molecular compound or an ionic compound? And do the same thing for 5. And that is all for part 2 of our part 3 summer lecture.